Good day everyone. Today we will discuss about stoichiometry. In this video, you will learn the meaning of stoichiometry. You will learn how to solve mass to mass, moles to moles, moles to mass, or mass to moles.
Let us define first the meaning of stoichiometry. Stoichiometry is derived from the Greek words stoichio, which means element, and metry, which means measure. Stoichiometry is about measuring the amounts of elements and compounds involved in a reaction, which means it is involved looking at chemical reactions and making measurements about reactants and products. Stoichiometry is quantitative in nature, which means we will be determining amounts of substances present.
Most of chemical reaction, there are three types of conversion. In stoichiometry, the first one is to convert moles of the substance to other moles of the substance, and you identify molar ratio. The second type is moles of the substance to mass or mass to moles of the substance. The third type is to convert mass of the substance to other mass of the substance. In short, the first type has single-step process, while the second one has two-step, and the last one has three-step.
Let's try to answer this first example. We have mole to mole. How many moles of hydrogen chloride are needed to react with 0.7 moles of aluminum? We have a given equation: 2 aluminum plus 6 hydrogen chloride, 2 aluminum chloride plus 3 hydrogen. In order to get how many moles of hydrogen that is needed, we need to follow 3 steps. First step, we need to calculate the ratio. We have 2 aluminum is to 6 hydrogen chloride, which is its ratio is 1/3. And we have 2 aluminum is to 2 aluminum chloride, and its ratio is 1/1. And last, we have 2 aluminum is to 3 hydrogen, and its ratio is 1/1.5. Step 2, find the moles of the given. 0.87 mole of aluminum are reacted with hydrogen chloride. And lastly, step 3. As Duke mentioned, mole to mole is a single process. So, calculate the moles using the ratios. We have the given equation: 0.87 mole of aluminum times 3 mole of hydrogen chloride over 1 mole of aluminum. So, we need to cancel out aluminum, and is equals to 2.6 of mole hydrogen chloride.
Now, we will talk about mass to mole. And the main objective here is you will learn how to solve mass to mole and the step-by-step process. And the example here is tin metal reacts with hydrogen chloride to produce tin chloride and hydrogen gas. How many moles of hydrogen chloride are required to react with 75.0 gram of tin? And the first step is list the known quantities and plan the problem. As the given here, 75.0 grams tin, and the molar mass of tin is equivalent to 118.69 grams over mole. And it has 1 mole tin equivalent to 2 mole of hydrogen chloride. And step 2. Here, we have 75.0 grams of tin times 1 mole of tin over 118.69 grams of tin. And then, we will cancel the grams of tin. After that, we will multiply the ratio, which is 2 moles of hydrogen over 1 mole of tin. And then, we will cancel the mole of tin to get the mole of hydrogen chloride. And the final answer will be 1.26 mole of hydrogen chloride.
Next, we have the mole to mass problem. Hydrogen sulfide gas burns in oxygen to produce sulfur dioxide and water vapor. We have the given equation. Hydrogen sulfide gas is reacted to oxygen to produce sulfur dioxide and water vapor. Question: what mass of oxygen gas is consumed in a reaction that produces 4.60 moles of sulfur dioxide? Step 1. We have to list the known quantities and then plan the problem. We have the given 4.60 moles of sulfur dioxide, and then 2 moles of sulfur dioxide is equals to 3 moles of oxygen. And then the molar mass of oxygen is equals to 32 grams per mole. Step 2. Just like what they said earlier, multi-mass problem is a double step process. So we need to multiply the mole of the given mole, which is 4.60 mole of sulfur dioxide, times 3 mole of O2 is equals to 2 mole of sulfur dioxide. And then we need to multiply the molar mass of O2 over 1 mole of O2. And we will find the answer 221 gram of O2. And that is the mass of the oxygen that consumed in a reaction.
The last one is mass to mass. Ammonium nitrate decomposes to dinitrogen monoxide and water. We have the equation ammonium nitrate to form dinitrogen monoxide and 2 water or 2H2O. In a certain experiment, 45.7 grams of ammonium nitrate is decomposed. Find the mass of N2O if the mass of H2O is 20.6 grams. So in this problem, we have 2 steps. The first thing we have to do is to list the known quantities. The given is 45.7 grams of ammonium nitrate, and the ratio 1 mole of ammonium nitrate is to 1 mole of dinitrogen monoxide. After all of that, we have to get the molar mass of the compounds. You can do that by getting the individual masses of the elements. Here we have 80.06 grams per mole of ammonium nitrate and 44.02 grams per mole of dinitrogen monoxide. The last one, just like they have mentioned earlier, mass to mass is a 3-step process. The first one is mass to mole, the second one is mole to mole, and the last one is mole to mass. So we have here 45.7 grams of ammonium nitrate times 1 mole of ammonium nitrate over 80.06 grams ammonium nitrate. So we can cancel the grams of ammonium nitrate to get the moles of ammonium nitrate. After that, we will multiply the moles of ammonium nitrate to the ratio 1 mole dinitrogen monoxide over 1 mole ammonium nitrate. Then cancel the mole ammonium nitrate to get the mole dinitrogen monoxide. And lastly, we will multiply the mole dinitrogen monoxide to 44.02 grams of dinitrogen monoxide over 1 mole of dinitrogen monoxide. And cancel the mole dinitrogen monoxide to get the final answer 25.1 grams of dinitrogen monoxide.
Now, let's practice some problems. Mole to mole. Sulfur dioxide reacts with oxygen gas to form sulfur trioxide. We have a given equation. 2 sulfur dioxide reacts to oxygen to form 2 sulfur trioxide. If 3.4 moles of sulfur dioxide reacts with excess oxygen gas, how many moles of sulfur trioxide will form? Now, pause the video and feel free to answer this problem. What we need to do is find the molar ratio between the sulfur dioxide and sulfur trioxide. So, for every 2 moles of sulfur dioxide that reacts, 2 moles of sulfur trioxide will produce. So, 3.4 moles of sulfur dioxide is multiplied by 2 mole of sulfur trioxide over 2 mole of sulfur dioxide, and we will get the mole of sulfur trioxide, which is 3.4 mole of sulfur trioxide, since the molar ratio of two substances is the same. Mass to mass. Methane can react with elemental chlorine to make carbon tetrachloride. We have the equation methane reacts to 4-chlorine to form carbon tetrachloride and 4 hydrogen chloride. How many grams of hydrogen chloride are produced by the reaction of 100.0 gram of carbon tetrachloride? Now, pause the video and feel free to answer this problem. First, we need to identify the molar mass of carbon tetrachloride, which is 16.05 grams per mole, and the molar mass of hydrogen chloride, which is 36.46 grams per mole. In each step, we can limit the answer to proper number at significant figure. But here, we will do all the three conversion on a single line. So, 100 grams of methane times every 1 mole of methane is equal to 16.05 grams of methane times 4 moles of hydrogen chloride over 1 mole of methane times 36.46 grams of hydrogen chloride is equal to 1 mole of hydrogen chloride. And then, cancel the like terms and we will get 908.7 grams of hydrogen chloride. Now, it's time for you to try and solve this problem above. Enjoy! Mass to mole and mole to mass. Propane reacts with oxygen to form carbon dioxide and water. We have the equation propane reacts to 5 oxygen to form 3 carbon dioxide and 4 water. How many grams of oxygen gas will completely react with 3.8 moles of propane? If 38 grams of water are produced in the reaction, how many moles of carbon dioxide were produced? That's all for today's video. I hope you learned something about stoichiometry. I hope you learned how to solve mass to mass, mole to mass, mass to mole, and mole to mass. Thank you for watching and listening. See you in the next video. Bye-bye!